Previous lecture, we calculated NPV for project A and project B, and we got 160.55 and 45.55 for A and B respectively there. Our decision rule now for NPV is accept if the NPV is positive or if the NPV is greater than 0. So if we want to come up with a model that just tells us what to do without us thinking, we can just say if we open bracket there, if this value is greater than 0, then we have to accept that project. Otherwise, if it's not greater than 0, which means if it's negative, otherwise we reject the project like that. So since that one is positive, we accept, and if we drag this and put it there, we get an accept for both projects. If these projects are independent projects, we accept both since they all add value. But if they are mutually exclusive, where we have to accept only one project, where the projects are competing or where we're acting under conditions of some capital rationing, where our capital is limited to 250, we will accept project A. Now let's check whether this works. If we change our cost of capital to 30%, you would see that project A's NPV would be minus 13.42, and that's an automatic reject decision. Okay, so that's that with NPV. Now let's just look at some advantages and disadvantages of using NPV as a decision rule for accepting projects. NPV is the gold standard of investment decision rules. Key benefits of using NPV as a decision rule: it focuses on cash flows and not profits, makes appropriate adjustments for time value of money, can properly account for risk differences between projects. Though best measures, NPV has some drawbacks: lack of intuitive appeal of payback, doesn't capture managerial flexibility, option value well. So those are some of the disadvantages of NPV. Now, if we want to address this issue of not capturing managerial flexibility, we will have to get some knowledge of what we call real options. Because if we are considering NPV as a decision rule or some of these discounting techniques, we are saying if conditions change in future about the project, we still have to finish the project. The project still has to continue. We can't expand, we can't reduce, we can't shrink, we can't abandon the project because we have to get what we actually budgeted for. So that's that with NPV. I'm sure you're going to carry out further reading on NPV. Let's look at the internal rate of return. Now, we're not talking about internal rate of return. By definition, internal rate of return is the discount rate that makes the NPV equals to 0. It's the discount rate that equates the NPV to 0. Now, the decision rule for internal rate of return is accept the project if the internal rate of return is greater than the required rate of return. Now, NPV versus the internal rate of return. Now, that's how we find our NPV. NPV is equals to cash flows. So if you know your cash flows, if you've got different discount rates, you get NPV by doing that. Now, in essence, when we are calculating internal rate of return, we are actually finding a rate where we have got R there on NPV. On internal rate of return, that R is equivalent to the internal rate of return if using it results in an NPV of 0. If using it results in an NPV of 0. So that rate, which gives us an internal rate of return of 0, is the internal rate of return. Okay, and what is the significance of that rate? It's more of a break-even rate. Under what circumstances would we break even in our investment, so that we know we accept the project if the cost of capital is in this region or if it is in that other region. So we accept the project if IRR is greater than the required rate of return. If the IRR, we'll see this from NPV profiles. Now let's see how can we compute the internal rate of return. Let's use a different set of cash flows here. Let's assume these cash flows. Let's assume these cash flows. I'm sure if we check here, these are the cash flows. This is the data that we want to use for that project. Now, it can be as simple as this. If you want to find internal rate of return, if we are going to say internal rate of return, IRR, what is the IRR of these cash flows? That one is saying 16%. Let's see what the actual number is. Let's increase. Okay, let's increase. You see, 16.13%. Like that, 16.13%. So our internal rate of return there is 16.13%. Now 16.13%, given that our required rate of return on those assets, on that company, on that project is 12%. If our internal rate of return is 12%, should we accept or reject this project? Now we said our discount rate there is 12%. 12%. And our decision rule, what did we say was our decision rule? Accept if IRR is greater than required rate of return. Now here, let's see the decision. What is the decision to take there? We are saying equals if IRR is greater than this one, then what? Then accept. Otherwise, reject the project. So in this case, we accept because our IRR is greater than the internal rate of return. We shall see what this means as we look at our NPV profiles. So for this one, there is a question there. Should you accept or reject? It's an accept there. Okay. It's an accept there. Okay. Right. However, if we are to find NPV, or in fact, internal rate of return, through a manual calculation, that would be the formula there. Okay, so we know already here, okay, we can copy this. In fact, we can have this going down there. Insert, let it go down there. Okay. Let's have discounting factor at 12%. 12%. And let's also have, okay, let's see what we get at 12%. At 12%, the discount factor would be equals to 1 plus the discount rate, which is 12%. In fact, let's put our 12% there, to the power minus the period. Now, we don't want our cells to move. Let's freeze that one. Let's fix that one. So let's have our 12% there. Let's remove it there. Discount rate at 12%. It's that one. So At 12%, what is the discounted cash flow? Is equals to that one multiplied by this one. Okay, so we'll have to do it like this. Those numbers we have, we say equals, we sum those numbers, what do we get? Get our NPV of 12,627.41. Let's see if we have got an NPV of 30%. Or I thought about 25%. Okay, this one was 12. Let's make it 15. Okay, let's make it 17. 17 is that one. Let's make it 16. So 17 gives us a negative NPV. Okay. Okay. 17 gives us a negative NPV. So we have 12 there. That's the NPV at 12%. Maybe let's have these numbers like this at 12%. Okay. So we said at 17%. 17%. What is the discounting factor at 17%? Now at 17%, discounting factor would be equals to 1 plus 17. Now this 17 has to be like that. Power minus this one. Okay. So we do it in that way. So what are the discounted cash flows at 17%? It would mean we multiply this one multiplied by this one multiplied by the cash flows. If we do multiply by the cash flows, that's what we get. And if you get that and you say the sum of everything there, it gives us NPV. So that's our NPV of minus 2463.25. Okay, now let's see. If we want to get internal rate of return through manual calculation, we say NPVA, right? NPVA is the NPV that we get at a lower discount rate. So that's the NPV, which is the positive NPV, NPVA, over NPVA minus NPVB. NPVB is the one which we get from the higher discount rate, which gives us a negative NPV multiplied by that one. So that's the formula for internal rate of return. Let's try and model that internal rate of return. Let's see. RA is the lower discount rate. Okay, let's try and do it this way. RA B NPV A RA, lower discount rate, is that one. RB, higher discount rate, is that one. NPVA, is that one. NPVB, it's this one. Now, we want our IRR there. Okay, so our IRR is equals to, okay, let's simplify this. Let's have NPV A minus NPVB. Have, what else do we need there? Let's have RB minus RA. RB minus RA. Okay? So NPVA minus NPVB is equals to NPVA, this one, minus that one. That's what we get. That other one, RB minus RA, is that one minus that one. Seeing that. So what is the product of those two? Because it appears these two, NPVA minus N over that one multiplied by R, they are being multiplied. So what is the product? Let's see the product of those two. The product would be equals to that one multiplied by that one. Is that true? That's the product? No, that's not true. We will have to say the product. It's on top, we have NPVA, we have this NPVA. So it will be the product of equals to that one divided by this one. Okay. Let's put this in brackets. Okay. Multiplied by 5%. So it would be that one. So our internal rate of return would be RA plus this. There we are getting 16%. Let's see, 16.18. The one which we got from the Excel something, it was 16.13. Okay, so that's our internal rate of return. We accept the 16.18 is correct. It's okay because there are a number of things which have been estimated in that formula there. Okay, so that's that with the internal rate of return. That's how we calculate the internal rate of return manually. That's how we calculate the internal rate of return manually.